Alright, in today's video I'll be sharing with you this tutorial. It's going to be a full tutorial where I explain all of the details here. We'll be creating this set of shelves. So what's most important about this is that I'll show you how to create the overall form, top, bottom, side, frame, and then also using isotrim to subdivide the interior. At the end, I'll also show you how to take this and be able to intersect them and have them in a way where they intersect the top and the bottom, and you have notch, so when you fabricate this will fit in perfectly. So if you're into parametric design, want to learn a little bit more about Grasshopper, want to learn a bit more about how to fabricate and create furniture, a lot of the steps that you'll learn here are going to be useful not just for this type of design, but for many other parametric designs. And a lot of the things that I'll go over here will be useful for other things. So if you get stuck somewhere, you can always go to my website. You can download the script, see how things plug in exactly. It'll be available for a limited time, but this will really help you understand how it all plugs in if you get stuck somewhere. So with that being said, thank you very much for being here. Hopefully you're excited to learn a little bit more, and let's jump right into it. All right, so to create this, we're going to start by creating the overall form. We're going to start with a rectangle. So let's go here, rectangle. We'll be using this rectangle component, which lets you plug in the X and Y size. So let's do that. Let's go to a slider to create a size for the X and a size for the Y. So I'll go here to the X size and increase it to, let's go to 60 here. Okay, so now that we have this, we're going to take the rectangle and we're going to turn it into a surface. So we'll go here to boundary surfaces. And now we can use this surface and extrude it to give it the height. So we're starting by creating the overall form. Let's go here to a unit Z vector for the direction, and then use a slider for the height. So I can just copy this one. All right, so now that we have this, let's now start by creating the overall frame. So we'll take this extrusion and deconstruct it using deconstruct VREP. This way we can start picking some of the different surfaces that make up this box and create the overall frame. So we'll take this extrusion, we'll hide it, and now there are different ways that we can pick the surface. If you want to know how this is organized, we can always bring in an area component, which means it's going to give us the midpoint. And then we can use a point list to have a visual representation of how this is organized. So if we plug in the centroids or the center points into the point list, we'll get all of the different way that it's organized. So it'll give us the numbers of how it's laid out. So let's go here and increase the size of the points. So now we know that this front face is 1, the side is 2, the other side is 4, the top is 5, and the bottom is 0, and the back is 3. So the reason why I say there are different ways to do it is because you don't necessarily have to use a point list to know how things are organized. You can always just use a list item and plug in the faces into list item. And now with the index, we can go from 0 less than, and we know we have 6 different faces for this box. So we'll go from 0 to 6, which we can now start at 0, which we know is the bottom one. And when you go to 1, you'll see that they will correspond to the numbers of how the point list is displaying. So 2 is the side. And so sometimes instead of using this, you can just cycle through them and know how it's organized by what number it lands on when you select the item. So we're going to start by, since we already have the point list, we'll bring this back. We're going to start with 5. So 5 is going to be the top surface. And now we can hide all of these faces and take this top surface and extrude it down to create the top frame. So we'll do extrude in the Z direction, so up and down. And now we'll use a negative component to extrude down. And now we can use a slider to give it the exact height. So we'll just go here, 2.500. So depending on how many numbers and decimals you plug in for your slider, that's how many you will get. Okay, so we have the top frame. Now we're going to create, so we can move this over and up, and you'll see why I'm doing that in a second. So now when we take this, slide it down, tap Alt. Actually, we'll do it with both of these. We'll slide it down, tap Alt. And now we'll move it to 0, so to the first one. And instead of extruding down, we want to extrude up. Why? Because we want the box to be the overall size of our shelves here. So we'll take this, delete the negative, bring in the positive. Now we can, let's say, use a 2 for the bottom, or let's say a 1.5. So we can have 2 different sizes, one for the top and one for the bottom. Okay, next we're going to go to 2 and 4. We'll start with 4. So we'll take this, slide it down, tap Alt. Actually, we'll do this one and you'll see why. Slide it down, tap Alt. We'll go to 4. But what happens is when we extrude it, here we have it in the Z direction. So we want to move it in the X direction. So hopefully you can see that here in the bottom left of your viewport, you'll see the XYZ coordinate system. We're going to move it in the positive X. So now we can use this slider into the X. We can delete the Z vector and plug this into that direction. And now we can do the exact same thing for this number 2. But in the negative direction, because now this is extruding to the outside. Now, in some cases, you might choose for them to be extruded out or extruded in. So just make those adjustments as you see fit for your design. Okay, so depending on how you have this laid out, you may want to keep the outside frame and the top one be subtracted. But in this particular case, we're going to use the top and bottom and use them to subtract and to remove the overlapping portions for the side 2 and the side 4. So let's go here to difference. And in some cases, I would stay away from using solid difference if you have too many different subtractions. But in this case, where we only have 2 things to subtract from, it's actually not that computationally kind of expensive for the computer to do that. So we'll take this extrusion, subtract the top and the bottom. And now we can hide this because that's the old one. We're going to do the exact same thing for the other side. And now lastly, I think we need to bring in the back face. So that's surface number 3. And so we can take this. Well, we'll take this. Actually, this one. You can pick any one of them. Just this one is already previewed. Slide it down, tap Alt. Go here to number 3, which is the back panel. And instead of extruding it in the Z direction, it's going to be in the Y negative direction. And then usually the back side is not as deep as the sides, just because that's kind of like the backing panel. And then we can use a solid difference to subtract all of them with. So it's going to be, the panel is what we want to keep. So that's this one. And now we want to also add the side and this side. And when we bring back, or when we hide this one, you'll see that now we have the back panel that has been subtracted using the other two panels. So what does this do? Let's now kind of review that. This is kind of one of the trickier parts, which is just to set up the overall design. So now we can change all of these sliders, and you can see that all of those design options that we made are consistent, and we can change those as we see fit. The next portion that we're moving into is creating the inside shelves. So for this, let's actually make the maximum X direction be larger. So I'm just increasing the maximum. I'll make this, let's say 120, and I'll make this 60, maybe that's fine. Okay. So we can also start labeling our information here. So I do like to route, some of these are kind of the final forms. I like routing them through an empty geometry component, and I'll show you why. Bringing them out here. And to organize things, I also like to do this. I'll show you the trick that I like to use. I like to line them up with the output, line this up with the output, take this, and then use the right arrow to line them all up to the right hand side. And then using this one down here, you can evenly space them if you want, but we don't necessarily have to do that. And like I said, I like to put them here because I'd like to group them, and then use top. When you group it, it lets you name the group. Bottom. I'll call this left. And that's viewing it from the front, but you can label them whatever you want. That makes sense to you. So let's go to right and back. All right, so the next step is going to be to create the shelving. So going back to our items, let's go back to this back item, and let's intersect where that lands with where the back is here. Since we know the back is a little bit smaller, then we need to adjust for that. So we'll go here to intersection, physical, brep with brep, and we're going to extract a curve where this brep B and this back brep A intersects. And notice that now we have a polyline at that location. So now we can hide this one. And when something is routed all the way from the back to the front, you can just leave it because it actually shows where it comes from. For me personally, I like to hide this one, and you can always bring it back to see where that comes from. Next is figuring out what size your vertical and horizontal shelving is going to be. So for now, we're just going to use a slider and offset it to the outside by that number. So let's first go back here and see that this is the left, this is the right. Oh, okay. So the left and right want to be consistent. So we can delete this number and plug both of those into 1. This way, when we look at these and we increase this number, they will both increase at the same time. So let's go here to 2. And if this is 2, then let's offset the distance, let's say by 0.75. We'll go from 0 less than 3.000. So now we have a new slider. It starts at 0, ends at 3 with 3 decimal points, and we can do 0.75 for this one. Okay. So now that that is the overall size of the shelving, we need to keep in mind that if we are to subdivide this evenly, we need to know how thick each shelf is, and we need to start it from the midpoint, from out here, from this midpoint, to out here, the other midpoint, and this way the shelves can be evenly spaced. So now that we have this one, we're going to copy it down here, and this won't make sense until I kind of show you why we have to do that. But when you just need to account for the thickness of your shelving for them to be evenly spaced within the overall frame. So taking this, we're going to now do a divide by 2, so /2, and this will give you a division of 2 in the B, and now it's 0.75 divided by 2, 0.375, and now we can plug that into the distance. So notice now that we have the overall size, then this one, which is where we're going to be subdividing this shelf. So now we'll take this, and depending on how you want to subdivide this, with this particular design, we're going to use isotrim. So I'll go here to isolate, or we're going to go here to boundary surface. Sorry about that. Now we can hide all of this. And with this surface, now we can divide it using isotrim. But you can also use another type of subdivisions, like we have Lunchbox, and there are different ways that we can do this. For this particular one, just showing you a regular rectangular square subdivision. So let's go here to divide, domain squared. We're going to go and divide it by 3 in the U and 3 in the V. So the U division is the vertical subdivisions, or the horizontal subdivisions, and then here V is going to be the vertical ones. And they may change. Sometimes the U and the V are changed, but in this particular case, that's kind of how it lands. So we'll do 3 and 3. We can hide this. And now we're going to pick the inside line segments. So we're going to join this B-rep. And the reason why we join it is because if we bake this, you're going to see that if I have these as separate, so I just baked it to show you, if we have these as separate surfaces, that means that this has 2 redundant lines, one for this one and one for this one. But when I join it and I bake it, you'll see that this is a joined B-rep, which means that there's only one line in between the two. And that is what we want. We want to be able to extract the B-rep edges. And now when you have B-rep edges, you have the naked curves and the interior curves. The naked curves are the outside ones. The interior curves are going to be the ones on the inside. So we want the curves using a curve component. I'm just going to plug the interior ones into this component, because when you have this component, you have both of them in one. Now, if you plug it into this one, you'll see that now we only have the interior ones. Next, we're going to take these curves and we're going to offset them. So notice when we offset it, it offsets to the right and then it offsets this way. So we need to give it the plane in which it's going to offset. So for this plane, we're going to use the XZ plane as the reference plane for it to offset. So now you're saying that it offsets relative to this XZ plane. So how do we offset this? Well, we have to offset it by this amount, which is the same amount as how much we offset it to the outside, and then by half. So we're going to do 7.5. But since we're going to do it to each side, we're going to do this component, which is half of it, in the positive direction. And then copy this. And then do the other half. So let's move these to 1. And then do the other one by the negative direction. Now I can delete this relay and then hide the wire here. And we can also hide this wire. So we have it offset to the right and offset to the left. And between those two, we're going to lock them together. This one and this one. So when we do this one and this one together, this one and this one together, this one and this one together, and this one together, we have these overlapping locks. What we're going to do now is to bring them together. We can't join it because they're overlapping, but we can use region union and then flatten the input. Now we can hide all of this, and notice that now we have a really clean set of lines. So now let's use boundary surface. And now we're going to extrude it the same amount as, well, first we need to move it to, in the negative Y direction, the same amount as the back. So we know that this is the back. And the depth is 0.5. So we need to move this surface. In which direction? Here we see that Y positive is this way. So we're going to go in the negative Y direction. And we don't need to put in a slider for this one because we already have one back here for the back. So using this output, and we can actually use this negative Y. So we don't even need to bring in a negative Y component. So let's go to wire display, hidden. And depending on whether you want this to go all the way to the front, then we can do this. We can extrude it independently. So extrude it in the negative Y direction. So I shouldn't have deleted it because I am going to use it. But it's going to be for, if this is 24 and this is 0.5, it has to be 33.5. But let's say we can extrude it by 20. Or we could do this. If you want it to go exactly to the front, we can do, we'll leave this here and I'll show you. It's going to be the frame size, which is, or the depth of it, which is 60. Wait, no. The 24 minus, so let me show you, 24, which is the depth, minus 0.5, which is 23.5 here, and it will make it exactly to the front. But additional to that, we can go here and add a plus, which lets us plug in another subtraction, -3. So also subtract 3. And this makes it so it extrudes it all the way to the front, but now this number becomes the offset amount from the front. So if we want only 1 inch to be offset from the front, this way you don't see, because we're going to subtract the shelves from the overall frame. This is going to be useful because then you won't see the notch from the front. Okay, so now that we have this, let's take a look. Let's hide all of this that we don't really need. And let's look at the shelves relative to all of this. So I'll bake it. I'll move it to the right. And then I'll go back here. I'll just hide the backing. And now we can take a look that between, so I'm creating a dimension between this one and here. We have 38.17 between this backside, 38.17, and between this one and this one, 38.17. That the reason why we have these being consistent is because we offset this halfway using the thickness of the frame to the outside and using that midpoint as a location of where we subdivide these. So now let's go back here and hide the wire display for this one, hide the wire display for this one. Now we can kind of look at it from the front here. And we can look at the number of subdivisions. So if we want more vertical subdivisions, they're going to be perfectly spaced. The horizontal subdivisions the same way. Okay, so now that we have this done, let's go back and kind of just change this back. The only issue that I see with this type of developing the shelves is that these are all together into one, and we may want the horizontal and the verticals to be separate. So in that case, let's go back. We have the overall, we have the center spacing here. And so here's another way of taking care of this portion. So if you have them all together like this, and that's okay, then this is good. But I've seen in other cases where, so we'll hide this and use this as an option. Taking this and then, okay, so we can actually keep this. I'll show you the trick on this one. If we bring this back, but we only do one set of verticals, and we copy all of this, but we do it to, so copying this over and bringing this to 1, and then here are the horizontals. So we can now tie this one and this one together because those are going to be consistent. This will make it so now we have these two. And what we're going to do here is we're going to be subtracting half of one and half of the other. Basically making sure that they intersect. So there are different techniques for kind of doing this portion. And if you have shelves like this, this is one way to do it. So taking, let's say, the horizontal shelves, we're going to move them in the negative y direction. By half of the depth of the shelves. So we know these are 22.5. So we'll do that divided by 2. So 11.25 in this direction. We can move If these are the horizontal ones, we'll move them in that direction. So we'll hide these for now, even though those are the ones we want to keep. And now we'll go to the vertical ones and use a solid difference, keeping the top ones and subtracting half of where the shelves are in the horizontal direction. So now we can hide this, and we can hide those because those are old now. So now we have the vertical ones with a notch halfway of the depth of the shelves. So let's bring back the horizontal shelves. And so now, as you can see, we can do the exact same thing, but rather than moving in the positive, we're going to move, let me show you here, the top shelves, or the vertical shelves, not in the negative direction, but in the positive direction. So backwards. And subtract using Boolean difference or solid difference. The horizontal shelves is what we want to keep. So that goes into A, and we want to subtract the ones that we shifted back halfway. So all we're doing is we're shifting the original ones halfway out and halfway in and subtracting them from each other here. So now when we hide this, now we have the vertical ones subtracted halfway, horizontal ones subtracted halfway, and we can make sure that things are working out here by selecting all of this, baking it, bringing it out here, and taking a look to see if they would fit. So they do. So now we can bring everything back here. And the last thing we're going to do is that now that we have these two, whether you want them to be, well, there are different ways that we can develop this. One is you can route out the holes for the vertical ones and the horizontal ones by subtracting and notching on the sides and on the top. And the other one is just subtracting it from the top and sides, so it's flush with the inside face. So in this particular design, we're going to do this. Use a solid difference. And we're going to subtract from the top and from the bottom. So I'll actually use both. So I'll use this twice. Subtract from the top and from the bottom. So using that as A, because that's what we want to keep. The vertical ones. So now this is going to be, if we use a geometry component, this is now going to be the top. And this is going to be the bottom. And do the same thing with the left and right. Solid difference from the left and from the right. Plugging those into A because that's what we want to keep. And then what we want to subtract with is going to be the horizontal ones. So now this is old. And we can copy these two. This is going to be the left. And this is going to be the right. Now we can hide all of this, except for the back. So these wires coming all the way from the back to the front here, we can hide the wire. I just think it makes it cleaner. Not that that's the purpose, but I do like to minimize a little bit of the visual clutter. So now we can see this and this. So bring this up, use two geometry components and plug in the vertical and horizontal shelves. So with this, now let's go back to the top and we'll start giving it some material so we can visualize this. So custom preview and using a color swatch. Let's see here. Okay, I'll copy this or use the top and bottom and sides the same custom preview. And then the vertical and horizontal shelves, maybe a different shade. And then the back side, which is this one. I'll create a new one just because this one's all the way back here and we need to plug it into this one. Now I'll hide that one and then bring this one all the way to the front. So now let's take a look at what this can do. So going back to the beginning, overall size, the depth, the height, then we have the dimensions for the top, for the bottom. So let's organize this then, if that's the case. So here's going to be X size or depth, not length. And I like to group it myself, but that's just a preference thing. Here I like to use a depth. And I group it just so I know the ones that I group and it has a green color, those are the ones that I can change. Height. These are consistent, so those I don't group because those are consistent to how we selected each side. This I like to organize by using this. This is going to be the top, bottom, left, right, back. Top, bottom, left, right. That's left and right. This is, so we'll make it one shelving size. the divisions. So if V is 1 for this one, U is 1 for this one. So those are consistent. This is consistent for both U and V. And then this and this are going to be this is going to be V. This is going to be U. This one, we can probably use the same surface as. Double click here and use this surface for both of those. And we'll move this up a little bit. This is consistent. This is going to be the offset, so we can leave it at 0 if we want it to intersect here. Sometimes that's fine. We can even do like 0.5. So this is base offset. And that kind of concludes this portion of the tutorial. Now, on the next tutorial, what I want to do is show you from this design how to add the details that will allow you to be able to CNC this. Why? Because there are going to be some notches that get put into the form. So this way, when you CNC it, you don't, when it turns the corner here, you'll notice that they're square. But when you have a CNC router, you're going to have the radius of your bit be a limiting factor here. So you actually have to kind of create some fishbone geometry here. So this way, when you intersect this one and this one, it's not visible, but it also intersects perfectly. And from there, taking these horizontals and verticals and deconstructing it so you can CNC this. So stay tuned. If you have any questions, let me know in the comments below. If you're not subscribed and you want to learn how to fabricate furniture, I am going to be getting more into that in the next tutorial. So thank you very much for being here. Hopefully you learned a few new tricks. And yeah, thank you for coming by, and I hope to see you in the next one. All right, so here's a tool that I've been using that has been super useful in terms of taking a product that I created from Grasshopper, and instead of taking hours and hours trying to stage it and put materials, I've been using ReRenderai to plug in a capture that I took from the Rhino viewport, and I plug it in right here and check out some of the results that I've gotten. So I started by keeping it simple. So this is overall just adding a wood material, adding some lights, and staging it within a room. This is another iteration with a little bit of a lighter wood. And then this one is inside of a residential area with furniture around it, but it's empty. And then here on the last one, I made sure to tell it that I wanted to have stuff inside. So what you're seeing here is the entire render output that I got from ReRenderai. It does it really quickly, and it really shows you what some of your designs can look like staged within a space. So I would recommend you checking that out. If you want to give it a try, you can always use the code that you see in the comment section below or in the description. And yeah, just wanted to show you a little bit more of how I've been rendering some of my 3D models.